gonna work. Okay, so now I'm going to be talking about the US Drought Monitor. Again, my name is Deb Bathke. I am one of the US Drought Monitor authors. This shows a just over 20-year perspective of drought. This is for the whole state of Alaska, the percent area in drought. The Drought Monitor started, or at least the archive goes back to January of 2000. So a lot of that abnormally dry conditions, a little bit of moderate drought, and then in 2019, we can see that we had some of that extreme drought in the state of Alaska. And I'll talk about what each of those mean in a minute. Next slide. So just to give you a quick overview, the Drought Monitor, what is it? What does it mean? How is it made? How is it tied to policy? Which will be a kickover, well, when I'm done, to Shelby to talk about that. And then the Alaska Drought Monitoring Process, which I'll hand off to Brian to comment on. Next slide. Someone's trying to get in. So what is the US Drought Monitor? The map is a snapshot of current drought status. So what's happening right now relative to past conditions. It shows us the extent of drought by the colors. The intensity, so more red, is that just me? Those colors look off. The darker colors are more intense drought. And then also gives us information on the relative length of the drought. Next slide. So to understand the map, we need to understand what drought is. And Brian stole some of my thunder. They're talking about drought. When we ask people what drought is, like we think we know what it is. It's when we have drier than normal weather that lasts long enough to cause water shortages. And the definition of drought starts to get complex when we think about what that means. So what is normal weather? Well, that depends on where you are. The normal or average amount of rainfall, the amount that you expect, that moisture, depends on where you're located. The amount that you get here in near Anchorage is very different than what you would get in the far northern part of the state, or even in the southeast part of the state. And I can't remember off the top of my head what the annual average is for here, 11, 12 inches. What is it?
I guess 18.
Is it 18?
Yeah. It's 17 for Anchorage and like 18, 19.
Okay, so I was way off. But compared to Southeast Alaska, which is what, 200?
Ketchikan's like 120 or
something like that.
Ketchikan's 150. Juneau's like 68 or something.
So
it ranges from the
huge
mid-50s
difference
to 150.
So it depends on where you are. It also depends on the season. Brian was talking about when it's wet, the wet season, and I'm going to totally slaughter this. Is it? Tell me, help me out here.
So this part of the state, the wet season usually kicks in like into July, but August, September,
okay,
and into October for sure.
Okay, so it depends on the season, but then the last part of this definition is enough to cause water shortages. Well, that part depends on who's using the water. What do you need it for? So for most of you in here, water, when you need water, is very different than someone who's in like winter recreation. So the type of moisture that you need and when you need it differs by sector or by user, or I guess sector would be the same. So for what the environment needs versus what someone in ag needs versus someone who runs a ski area, what they need. So drought looks very different depending on all of these characteristics. Some people refer to them as drought definitions. I like to think of them as more of perspectives or the lens that you're viewing drought through. Research into drought definitions or perspectives or lenses can yield hundreds of different definitions of these. Basically, they've been kind of condensed down into 5 broad categories. Meteorological drought, so those are a lot of the things that Brian talks about. How much precipitation did we get compared to normal? How did temperature impact that? Agriculture starts to look at things. When does that drought start to impact agriculture or plant health or soil moisture conditions? Hydrological is when do we start seeing it in our stream flow or in our groundwater? Ecological is the newest perspective or definition that we look at, and I was part of the team that worked on coming up with that definition, and that came out in unseen dates just gone. I think it was 2017. Is that what that was? Do you remember? About then? 2017. So ecological drought is when it starts to impact some of those natural systems, may start to impact ecotourism as well, ecosystem services. And then socioeconomic is when we see the impact and the effects of drought on our goods and services. Next slide. So the US Drought Monitor is not just an agricultural map, even though we're here to talk about agriculture. It tries to capture all of those different perspectives on one map. And how do we do that? We look at the amount of moisture and the availability and the deficits across different parts of the water cycle, which hopefully everyone learned about the water cycle. And I should know this because my son's 10, you know what grade in elementary school, but so we look at things like rainfall. How does that compare to normal for a certain time of year? Snowpack, if that's appropriate. Humidity, evapotranspiration, vegetation health, stream flow, soil moisture, groundwater, lake reservoir levels. We look at all of those types and pieces of information. Unfortunately, we don't have all of those observations everywhere. Next slide. We also, for the drought monitor, we look at those deficits and surpluses across different timescales. So we look at what's happening this week. How does that change what the map shows? We look at information on a monthly basis. So how does this November, how is that shaping up compared to all Novembers throughout history that we have data for? We look at it on an annual basis, on a seasonal basis. In cases like the Western United States, where there's been drought in place for, I can't even think how long we're going years. For years, so multiple years. So we look at that across all these different time scales and try and capture that all on one map. Next slide, I think, maybe. So, yes. So the US Drought Monitor tries to synthesize all of this information on one map. Anyone want to take a guess why it's all on one map? When the concept of having a US Drought Monitor was first thought of and in its development stages, that's what the decision makers, the policy makers wanted. They wanted one map to show where drought was occurring and how intense it was. So one map we have. Does this seem like an impossible task? Yes, trust me, it is an impossible task. So what do the colors mean on the map when we look at it? We have none. So Alaska, of course, since I'm here doing a drought workshop, there's no drought. Because that's the way it works. We have yellow, and Brian referred to that. That's abnormally dry. Those might highlight when you put them, I don't remember. Oh yeah, okay, they do. So abnormally dry is technically not drought. We use that to refer to areas that might be going into drought if conditions continue. So a drought watch, if you will, or areas that are coming out of drought that are still experiencing some lingering impacts or effects of the drought. Then we have 4 categories of drought, and I'm not sure why that is showing up as gray on there. This is supposed to be orange, beige color.
Yeah, should be more orange.
And it shows up that way, or peach color, it shows up that way on the screen, but it's not showing up here. And those are moderate, severe, extreme, and exceptional droughts. So increasing intensity, the warmer the colors and darker the colors get. So as Brian pointed out, we have to go back to July to see that drought status. Did they show up that way on your map? They didn't, did they?
It's the projector.
When you had it up though, they showed up normal.
No, it looked like that.
Did it? Okay. Never mind. The map also shows us relative timescales of drought. So where there's an S, like, and I don't think those like on this one. So an S in the Pacific Northwest or over North Dakota, that's generally used to indicate moisture deficits that have been around for 6 months or less. If you see an L, we have an L anywhere, a plain L in southern Nevada and the Southwest, and then over parts of the East Coast. Does anyone really know all the names of all those little tiny states? That represents longer term drought. So drought that's been around for 6 months or more. It may be wet in the shorter term, but they're still overall. So they may have had a wet September, or maybe they got some rain, but still when you're looking out over those longer time periods, we're seeing pretty substantial deficits. So that's what long-term drought shows. And then when we see an S and an L together, so right over Nebraska, that means we have those means I can't stand up. That means we have those long-term deficits, but we're also experiencing short-term deficits or seasonal deficits superimposed upon that. Next slide. And then I like to point this out. If you go, and I still forgot to add the website to it, it's droughtmonitor.unl.edu. You go to the website, there are lots of different tools. You can find historical maps, you can find the time series like I showed for different areas, so county, river basin, all types of different areas. But from the main page, if you scroll, so I'll have you click, there's a narrative that in addition to doing the map, the author explains any changes they made that week. I know I don't expect you to read that, but if you click again, for Alaska, it was really easy for the author. There were no changes because there is no drought in Alaska right now on the map. Next slide. So what do these colors mean? How do we decide what color goes on the map and where? So these drought categories are based on historical likelihood. So how do the conditions now compare to whatever history we have for the station? And to do that, we use percentiles. And if you have kids, you've heard of percentiles before, right? Like my kid is he's 10, he's in the 90th percentile for height. So he's tall. That means if you had 100 kids his age, only 10 would be taller than him. He's in the 50th percentile for weight. So he's tall and he's skinny. It's the same thing for the drought monitor categories, and I'll show what that means. So here is annual precipitation for here, and I've highlighted some years. So let's see, the annual precipitation with the most was 1930 at 25.78 inches. With the least was this only goes up to 2019. This comes from a tool that we have called the Drought Risk Atlas, and so you can get temperature, precipitation, you can get different drought indices, so mathematical combinations and computations. So that's why we don't have the most recent on there, but 1969, 9.84 inches. So it shows you the top 5 highest, the top 5 lowest. In the next slide. So to do percentiles, this process essentially takes that data and it ranks it, sorts it from the most all the way down to the least. And I always use stations I always use 100 years of data, so I don't have to calculate math on the fly in my head, because that would go wrong. But 100 years of data, the year with the most occupies position 100 years, and with the least is position 1. So it's ranked in order. So a drought that is ranked or that shows up as exceptional drought on the map takes up positions or percentile 1 and 2. So the lowest 2 years for that variable, so in this case precipitation, for that time period, which is 12 months. And if it's extreme drought, it's positions 3 through 5. Severe drought is 6 through 10. Moderate drought is 11 through 20, and abnormally dry is 21 to 30. So in order for it to show up as color on the map, it's got to be in that driest 30 years or 30% within that period of record. Now we do the same thing for every variable, every product that we have. So soil moisture, temperature, precipitation, evapotranspiration, any indicator of vegetation health that we have, all of those that you saw, stream flow, and for every time frame. So we have what this product looks like for the last 30 days, 60 days, 90 days, all the way up to 5+ years in some cases. And all of that information is mapped. The United States does not have a single agency that's responsible for drought monitoring. So you said you were NRCS, right? So we grab data from NRCS, pull it into our system. We grab data from NOAA, pull it into our system. We don't produce any of this data, we're users of it. We grab from the Climate Prediction Center data from them. We grab data from USGS. Eddie, I think, comes out of NOAA at University of Colorado. It's a drought index. So we grab all of this data, bring it into a GIS. Each of these is a type of drought monitoring product, an index, or an indicator. And when I expand it, it will have multiple time scales, whatever's available. So all in all, for the lower 48, I have probably 160 maps that I look at. When I go over here to Alaska, I have 1, 2, 3, 4, 5, 6 maps that I can pull for Alaska. So just showing you kind of that difference. So when I made the comment at our last meeting that whatever the state team sends me, I'm not going to question it. I'm sitting in Lincoln, Nebraska. I look at the data, but the number of points that I have on any given week in here, they might be like right here. And there's literally nothing that I have access to up here. So who am I to question the local data that Brian and Rick and Glenn, is it? Not Glenn, what's the other person's name?
Gene.
Yeah. Gene. Okay, next map. So this is what the process looks like. And just kind of click through these. So first we take all of the data, these maps, we put it into our GIS system. We look at drought impact reports. So what kind of effects is the drought having? Some of these are scraped from the media. Some are from people like you that can input them in either through COCORAS. Who's heard of COCORAS? So COCORAS, or through the National Drought Mitigation Center's. See, I told you I like to walk around. That's why it doesn't work there. Through our, where is it? Various tools to report impacts. And there's one in your folder called Help Us Record Drought Conditions Through Seymour. Anyone can do this. It kind of walks you through the process. You saw the number of things I had to look at for Alaska versus the rest of CONUS. So these are really, really important. It's your way to let us know what's happening with drought and get that information in front of the author. I will be the first to admit that this isn't the most intuitive process. So if you ever need help, feel free to shoot me an email, give me a call, and I can walk you through it. Or if we find a bunch of people want to know more about it, we can hold a virtual training with it, and Holly and I can work together to arrange that. The next step. So here's the data side. Here's me as the author. And my next step in the process is I create a draft map. And I send it out to this listserv of folks and get feedback and input on it. So, Brian, I believe you are on that listserv. And you can join that listserv. There's a couple requirements. You have to love email. Love it so much that you get 100 and some email messages between Monday and Tuesday. And then your email extension has to be .edu or .gov. And we do that because there's money dependent on this map. And so we try and make it so that people providing the input don't have a financial incentive to make it work. And then the last thing is we have a final map that's released on Thursday. So this is a back and forth process. Next slide. Drought Monitor authors, there's currently 9 of us, spread different agencies. In order to be a Drought Monitor author, you have to work for a regional or national center. So for regional, we have the Desert Research Institute in Nevada. We have Dave Simmerall. He's our one person there. We have 3 at the National Drought Mitigation Center. We just hired our 4th. We're super excited. It means instead of doing 6 weeks a year, I get to maybe do 5 weeks a year of the map. And then we have a few in DC with NOAA agencies and the US Department of Agriculture. This listserv with experts. This is as of September, how many people are subscribed. I think in Nebraska, we have the most at 30, and that's just because the National Drought Mitigation Center is there. And we have a lot of, Tanya's probably a stalker. You're not on.
I'm not on it.
You're not on it. So I have a lot of people who watch the listserv, but don't necessarily contribute information in on the drafts. I know Holly's on it.
I was gonna say I'm a stalker. I'm just watching. Hey, Alaska, did you see they changed something?
So for Alaska, we have 5. So it's you, Jean, Aaron, Rick, and maybe someone who moved on that forgot to have this. Oh, you're on? Yay! So good.
I'm also a stalker.
That's
The listserv also does not use like subject lines.
Right?
Usually it's some totally nonsense.
Oh, don't get me started on that. For a long time on the listserv that there's other technology out there, but I don't make those decisions. So next slide. So we send out multiple drafts. Some people send out, ideally you will be sending more than 1 draft. There is one author that maybe sends 1 or 2. I send anywhere between 3 or 5 drafts and send it out with emails that say, this is what I changed, where I changed it, and why. And do that a bunch of different times. People like Brian or Rick will say, wait, I don't agree with that. You need to do this or this or that. You know, so it's like having 100 emails. Tell me what to do. So this is an example with Rick. It was at 5:51 a.m. I sent Rick an email saying, I'm this week's author. Do you have any input? Last week's author said he considered removing D0 from Kodiak Island. The lone data point shows up as normal 90 days out, but progressively worse after that. So we're seeing longer term deficits. What are your thoughts on Alaska? And then he sends me an email back that says, it's some tough calls. Here's what I'm looking at. And I've CC'd Jean in case he has additional comments. Next email. I think this is what I drew in based on his description. And notice the 1, 2, 3, 4, 5, 6, 7, 8 points for the whole state that I have to make a call on. Rick says back, this is what I was thinking. You don't know what you're talking about. Or I have more data that I can see that you can't. And then another one that says, oh, then I said, okay, great, thank you. We'll go with that. For the next one, drought impacts.unl.edu. You can find links to COCORAs. You can find links to ways to report drought impacts so that we can take that into consideration. And areas where the extent that we use impacts depends on the type of information we have is kind of a survey that you can provide. It depends. You can tell a lot from the impact report. It's tied to, as Shelby's going to talk about, to some USDA programs. If it says, I need money, we're in D2, probably not going to pay as much attention to that as someone who says, it's really dry here. I've had to start irrigating when I don't normally. The last time I saw it this dry was in whatever year, information like that. Next slide. We use a process that is called convergence of evidence. So are all of these different pieces of information telling the same story? And you can just click through all of these. So we start with that physical data. We look at the drought impacts. I think there's 1 or 2 more clicks. We look at that feedback and interpretation from Brian or Rick or whoever's doing the Alaska part. And ideally, I think there's 1 more. We're looking for this period where those overlap. Is that always the case? No. Is that frequently the case? Maybe. But that's ideally what we're looking for, is to get everything telling the same story. Usually it doesn't if we know that it's a rapid onset drought, to use the flash drought example that you talked about. We had that situation in Arkansas. We knew from the impact reports that conditions were dry really fast and it was really impacting ag. So we focused on those short-term agricultural indicators and were they converging and telling us the same thing. With the drought monitor, typically we'll only go 1 category at a time, especially for worsening conditions. Do we ever do more than that? If we do, it's on the erasing drought side, and that would be mostly in places where a tropical storm comes through and dumps a year's worth of rain in a day. So next slide. The final map released today, Wednesday. It's released tomorrow morning. So every week there's a new map. Next slide. Authors do 2-week shifts. People say, oh, it'd be great if the same person did it the entire time. And I'm like, no, it would not be great if the same person did it the entire time, because it's a lot of work crammed into a short time. So we do 2-week shifts and we try and rotate every 2 weeks between the agencies. When I'm done with my shift, I send my files to the next author. So they don't start from scratch. They start from my last map, and then they move the lines from there. Next slide. The data for the map that is released, oops, I put that wrong, tomorrow on the 17th. The cutoff period in Alaska time was 4 a.m. on Tuesday. So any precipitation, rain or snow that fell up to 4 a.m. goes on this week's map. Anything that fell at 4 a.m. and 1/10 of a second goes on next week's map. So it can be really hard if you have an event that's happening over that cutoff period. So last data point, if you want to just click all of the next ones through. Usually we start on Monday, we send out multiple drafts between Monday and Tuesday. If there are state calls, I think Brian will talk about Alaska. Some states have official, like, weekly coordination calls with multiple agencies, and we try and listen into those when we can. So we do that on Tuesdays, multiple drafts. On Wednesday morning, we send out a near final draft. Tuesday night's really, really super late. Wednesday's really, really early. Usually do input cutoff. Would be about 11 Alaska time, I think. And then the final files and narrative have to be sent to our GIS and web tech team by what would be 2 p.m., 2 or 3 p.m. Alaska time, because it takes a good 12, 15 hours to process all of the statistics in the data. Because for each area, you can click on whether it's a county, a region, a river basin, it'll tell you this percent of this land area is in this amount of drought. And that includes this percent of the population and things like that. So they calculate all of the statistics. And then the map is released at, I think I had my time on, maybe not, 4:30 a.m. Alaska time. This is my recruiting poster. We're always looking for new authors. So if you work for a national agency, you will get no sleep. And when you think it's done, you're not really done, because then the phone calls and the interviews start. So I don't know if I've done, I think I've done one interview in Alaska. Usually I just refer them to Rick or Aaron if it's the Southeast. But if you have questions, there's my email. Call or email anytime. I'm happy to answer questions. And why is this important? This is my, well, that's not quite my handover. We'll hear that in a second. But Brian is going to talk about that state version. Each state does it differently. Some states we don't hear from at all, ever. Arkansas, ever. Other states we hear from every week. Some states we hear from every other week. Sometimes it's once a month, depending on, like during the dry season, states may meet monthly and send input in. But it is important to get information in the dry season because of that 1 week time it takes to degrade people. It's one severity level at a time. And you'll hear about that when Shelby talks. So, and even though it's a dry season, especially if you're having really warm temperatures, I'm thinking California with this, that they say it's dry season. We don't have drought, it's always dry. But if your temperatures are a lot warmer than normal and your winds are stronger than normal, if you're starting your growing season with 0 soil moisture, it's completely zero, that's going to make a difference. All right, you are up.
Brian, do you want to just give a little input on what
Alaska
process is?
Yeah.
And if you ever want to do things differently, I'm happy to share ways other states do it.
So as Deb mentioned, so Rick Tillman, some of you know Rick Tillman, he's former retired National Weather Service, but he works at the University of Alaska Fairbanks at ACAP, Alaska Center for Climate Adaptation Policy. It's a NOAA-funded regional organization. And every Sunday during the dry season, or during the warm season, and then as needed other times of the year, Rick will, he'll do the first draft of a map, he'll circle in some areas. Actually, he'll take the previous week's drought monitor and cross stuff out or add some new lines in. That's on Sunday afternoon. Then he'll send that to me and Jean Petrescu late on Sunday and ask for our input. We'll make changes or not. And then on the end of the day, Sunday, I then send that out to someone from the National Weather Service office in Juneau, Anchorage, in Fairbanks, and ask for their input by the end of the day, Monday, so that then we can send a final state version in on Tuesday morning. Rick usually does that. And, you know, the idea is that someone from each of those offices has their ears to the ground on what's going on regionally. So in Juneau, their drought concerns are hydrological. They are the reservoirs filled up? It is in the winter, is there sufficient snowpack in the mountains that'll melt off in the summer to keep that? And that's for hydropower production. Okay. That's not a concern here in South Central. Our concern is more in the valley here is more agricultural, but also a water supply, because a lot of communities have a water supply lake, and then fire. And then the interior, it's almost all about fire. So we, you mentioned you had like 6 things you look at, and we look at 2 of those. And then we add a third one, and for us, it's the most important one, and that's what's called the buildup index, the BUI. It's a Canadian index that's very applicable broadly to boreal forest regions. And we also look a little bit at the SPI, Standard Precipitation Index, and some precipitation rankings. And then we also, because we have a lot of data sparse areas, sometimes the tail wags the dog, and we look to see, hey, are there fires burning? Well, if there's fires burning, it's probably dry. Okay, and so ideally we get out in front of that. We're identifying dry areas before they burn. But here in Alaska, especially in forested areas, well, like 2019, right? Fires, drought. Okay, so May of 2019 was the wettest May on record. Okay, but we turned on a dime. We got warm, dry, fast, and within 2 weeks, fires going up everywhere. Okay, our indicators couldn't catch up with that, and so sometimes again, we see the fire. Oh, if there's fire, color in some drought areas. So that's our general process, and we also we're listening in on news reports on here and from the interior and from other places, but because the drought concerns are different in different parts of the state, we really can't have just kind of a one-size-fits-all approach. So that's our procedure, and it works for us. At our 3 statewide offices, the person we send it to there is what's called the warning coordination meteorologist, and they send it to different people in their offices for comments. So it's not just those 3 people that are looking at it, maybe 6 or 8 or 10 different people that are looking at it.
And some states, yours is Weather Service. Not that you only look at Weather Service products and really pay attention to them.
Right.
Other states have. When I was in New Mexico, we had NRCS, USGS. We had our state secretary of ag. We had different perspectives like that. In California, it's pretty much Weather Service folks there. So it just depends on the state, who your network is, who you have. Sometimes,
and from a state point of view, we don't have any state officials that do
Anywhere
anything
that's
with water on
right.
the water supply side of things.
But it doesn't have to just be that. I'm on the Nebraska state one as well. They just put me on it, but and I grew up in a rural community, and there's not data up there. And the state discussion was like, well, should we move this to D3 here? Does anyone have a feel for what's happening on the ground? And I said, I have family from there. Let me reach out. So I contacted my cousins, and one works for John Deere and happened to be out with his parents, like setting fence posts. So he gave some information. One works for a company that places like burial vaults. And he said back, well, I set some vaults here, and here, and the soil was dry all the way down to the 6 feet that we set it. And so like information can come from places that like nobody thinks, wow, those are for that part of the country, that's great information, because we don't have soil moisture networks. So don't think that any information that you have isn't useful, because it can't be.
And we welcome information coming from anywhere. We don't see it as we're in this tight control of this competitive information.
And the question is, do you want the information sent to you or through that drought reporting toolkit? Rick said that he preferred to get it through that because it's all collected.
Right.
But it's totally up to you if you prefer.
Yeah, I'm agnostic on that, but
okay.
What Rick said makes sense. So
in Hawaii, the Captain Kadama from the National Weather Service said, just email me. I'm not going to go look somewhere else. Just email it all to me.
Well, that would have been my first answer.
Okay,
but what Rick said made sense, having that kind of record for it. But there is a sending it outside adds another layer of, a data point of communication that is required extra work from someone. It's generally easy for us just to draw a line on a map or erase a line on a map based on quick emails.
I was just going to mention one drought impact that hasn't come up yet. And Holly, I don't know if we have anyone from off the road system on the phone, but for those of you who are not from Alaska, like many of our communities are not on the road system, and the way they receive supplies in the summertime is often by barge. When water is really low, the barges can't get upriver, and so when I worked at the River Forecast Center, that was one of the situations that we would provide information about. Barge operators would call us, and that actually can include, some of these communities have been encouraged now to put in high tunnels, and of course, they're not going to be flying in fertilizer. They're going to be putting the big inputs and things on barges. So that is not going to respond quickly to these flash droughts, but there are often in the springtime, again, at that super dry season, not all of the snow melt has released either, and they're trying to get that very first barge in. They haven't been supplied then for 6 or 7 months, and so getting especially that first barge in during that really dry part of the summer can be challenging.
We had a situation this last summer where in June we were starting to paint yellow D0 and D1 on the map while we're having record high flows on rivers. And, I had someone from the RFC, the Forecast Center, said, sure about this? Look at these river levels. So we had snow in the mountains, record high river levels, and forests on fire all at the same time. And that you have these conflicting signals. And in that case, the fires took precedent. If you have one indicator that's wet and your forest is on fire, it's probably dry.
For those who are listening via Zoom, we'll email links to this information that we're talking about. I mean, we can send it to everyone because you can't just click on the paper to get it. So we'll send the links out to these different products and tools that we're talking about. So
Yes, excellent. So we went into the drought monitor, so you understood what went into that and how important it is your observation for our progress observations. I know Andrew does that. I appreciate that. Or if you were thinking about adding in reports, it'd be great to do that for Seymour.